Alright, let's get started with lesson 2.08, Definitions and Biconditionals, Part 1. Don't forget to give me your course number and section number with all communication to me. So let's look at our objectives in this lesson. We're going to define and identify adjacent angles and biconditional statements. We're going to determine if a statement is a definition. And we're going to write the converse of a given statement. Some terms that we're going to be using today. Adjacent angles are two angles with a common side and a common vertex, but with no common points in their interiors. A biconditional statement is a true statement that uses the phrase if and only if, and whose converse is also true. So first let's look at definitions. If a statement is a definition, then both the original statement and its converse must be true. So the original statement and the converse have to be true for it to be a definition. So here's our statement. If two angles are adjacent, then the angles are coplanar, share a common side, and have no interior points in common. Okay, so here's my if and then. So remember, your converse is you're going to flip those. So here's the converse. If two angles are coplanar, share a common side, and have no interior points in common, then the angles are adjacent. Okay, those are both true. So this is a good definition of adjacent angles. Now let's look at biconditionals. If a statement and its converse are both true, then the statement is a biconditional. Written using the phrase if and only if, which is abbreviated like this, IFF. I don't know if you've noticed this, but math people, we don't like to write a lot of words. We like to abbreviate everything. Here's a symbol. See, it's got arrows on both ends, just like a line. P implies Q and Q implies P, so it works both ways. Okay, the original statement, P implies Q, and the converse, Q implies P. The definition of adjacent angles can be rewritten as follows. Two angles are adjacent if and only if they are coplanar, share a common side, and have no interior points in common. So let's look at some examples. It says for each statement do the following. Write the statement as a conditional statement in if-then form. A car is an automobile with four wheels. So you could take part A and rewrite it to say if an automobile is a car, then it has four wheels. Part B says determine whether the conditional statement is true or false. If an automobile is a car, then it has four wheels. Let's see what B says. True. Okay, although I think there's cars out there that only have three wheels. I'm not positive about that, but I guess we don't call them automobiles then. So here's part C. Write the converse of the statement. So I'm going to take this if-then statement in part A and I'm going to flip it. If it has four wheels, then it is a car. Okay, that's part C. If an automobile has four wheels, then it is a car. Determine whether the converse is true or false. Let's see what it says, because I know what I say in my head. False. Okay. Now, I would say that's false because it could be a quad runner or something like that. Doesn't have to have, doesn't mean it's, or it could be a wagon, a horse-drawn wagon. Doesn't mean it's a car just because it has four wheels. Okay, on E, it says, explain why the original statement is a good or poor definition. Oh, it's long. It says, the original statement is a bad definition because other automobiles have four wheels. To make the definition better, add more information about the car. Okay, more info. Okay, in this example, part A says write the converse and the biconditional statement. So If two angles form a linear pair, then they are supplementary. So remember, when you write your converse, you're flipping the if and then. So you're going to say if they are supplementary, then the two angles form a, well, you're going to say if two angles are supplementary, then they form a linear pair. So if two angles are supplementary, then they form a linear pair. Here's what the biconditional would look like. Two angles form a linear pair if and only if they are supplementary. Okay, so I wrote my converse, okay? This is the then and this is the if. Okay, I just flipped them. When I'm writing my biconditional, okay, I'm going to use my original statement. Two angles form a linear pair if and only if they are supplementary. Okay? Part B says determine whether the biconditional is true or false. Sample answer. It's false. Two angles could be supplementary but not be a linear pair, because remember, you could have one angle that's 100 and another angle that's 80. When you add them together, they're going to be 180. That doesn't mean they're a linear pair. Okay, here we are we're writing statements again. It says two congruent angles have the same measure. If two angles have the same measure, then they are congruent. I like it. I like it. Okay. Hold on, let me look at something. Two congruent angles have the same measure. So if the two angles have the same measure, I was making sure that the if and then were flipped, then they are congruent. Okay. The biconditional. Two angles are congruent if and only if they have the same measure. Ooh, I'm liking that one too. So part B says determine whether it's true or false. And it's true. That could be why I liked it so much. And here's another example from your lesson. It says name 4 adjacent pairs in each figure. Well, if you look, it's any pair of angles that are right next door to each other. Okay? So they said angle 3 and angle 1, angle 4 and angle 3, angle 2 and angle 1, angle 2 and angle 4. That's just 4 of them, because I could have come down here and said angle 5 and angle 6, angle 6 and angle 8, angle 8 and angle 7, angle 7 and angle 5. They're also adjacent. What we talked about in this lesson today is that a statement is a definition if the statement and its converse are both true. We call such statements biconditional statements. The phrase if and only if, also written IFF or, oh my goodness, I don't know what that goobity gob is, indicates both a statement and its converse are true. And then you have adjacent angles or two coplanar angles that share a common side and have no interior points in common. After you get finished watching this video, you should be going through the LMS and reading about compound statements part 2 and completing the study guide. Also, read through pages 47 and 49 in the reference guide. Complete the following problems in the problem set. And when you get finished with those example problems or practice problems, but before you take the quiz, give me a call or IM me or something if you have any questions. We want to make sure you understand this. Then you're going to take the quiz. And that's it for this lesson. Thank you for listening.